everybody. Welcome back to Planet X News, July 22nd, 2021. Ladies and gentlemen, I've had a bunch of people sending me emails concerning an incoming CME. I believe a lot of them were hearing this on YouTube and probably some other avenues of social media. And I pay attention to our space weather every single day. And believe me, if we had a major CME coming towards the Earth, I would have already notified everybody about it, and we would have been looking at it. Looking at the current space weather condition, the sun is getting very, very active. Currently, right now, there are 6 sunspots, 3 in the northern hemisphere of the sun and 3 in the southern hemisphere of the sun. And as I have mentioned several times before in previous videos, I did say that this is kind of the pattern that we're going to see. We will start to see groups of these sunspots forming just above the equator, just below the equator of the sun, north and south. And that will continue, and that will be a progression as we move further into solar maximum that we're going to have to keep a watch on. What we're looking at right now is the NOAA Space Weather Prediction Center's model of this CME. And as you can see, let me get my cursor going here. We have the Earth right here, the sun right here. And as you can see, when that CME went off, it is heading away from the Earth. It was not directed to the Earth. Now, we will get just, a little glancing blow, as you could see right here. So this CME is going to spread out pretty rapidly and very, very wide, as you can see here. But again, folks, nothing to really worry about. Your typical normal space weather. So let's jump into what is actually happening. Now we're over here on the cactus model. Okay, so let me go ahead and just get a full screen going here. And you could see just from the period of the 17th of July to where we are right now on the 22nd of July, you can see all of this coronal mass ejection activity. Each and every one of these is a coronal mass ejection. So we could take a look at, let's take a look at this one. This one occurred on the 20th, and we'll go ahead and pull it up. A kind of mild, nothing really to write home about. Now, we are probably going to see some additional activity. Oh, let's see. Okay, this is the 22nd. I would say pretty close towards the end of the month, we'll probably start to see some larger coronal mass ejections coming from the western limb of the sun. So for all of you, that would be this area here. Eastern limb of the sun over here, western over here. Reason being is, once again, this Planet X stellar core is in a 28-day very acute elliptical orbit. It's going to be coming straight up through here, and that's when it loops around the sun. But at this period right here, this is usually towards the end of the month. Okay, so this is going to be the time where we will probably get another decent look at the main core, and then the others kind of follow. And again, timing is everything. It will, I could guarantee you, it will produce a pretty large coronal mass ejection, or possibly even a few of them, depending on the positioning of these sunspots. Yeah, we may see a few. Some of them, there is a high possibility, may be directed towards the Earth. And this is the caution that I talk about and I've been talking about in the previous months. Moving further and further into solar maximum, these are the threats that we will be up against for a period of 11 years. That is the cycle that the sun goes through. 11 years solar maximum, 11 years solar minimum. When it hits its peak, and that's normally between the 5th and the 6th year, then you start to see a very slow decrease. But that slow decrease is still very, very active. During this solar minimum period that we have gone through, it just seems like the sun never went to sleep. It was very active, constant coronal mass ejections. Science will explain it to you in some other way, but I've clearly shown all of you that the interaction between these stellar cores, as we call them Planet X, as they orbit around the sun, as they gain their closest points during their orbit, it produces the coronal mass ejections. So how can you have such an active period in a solar minimum without another catalyst creating that activity? But again, mainstream science will never ever tell you about that. They'll make up some other excuse, we know that. But let's go ahead and jump back to here. So you could see all of these are very large, pretty substantial coronal mass ejections. We could take a look at this one. And this was on the 19th. And that was pretty heavy duty. And there's going to be a period of time, folks, where these are directed towards the Earth. One good thing that will always kind of play in our favor is the acute elliptical orbit of these objects, especially the main stellar core Planet X object that's very, very large. You know, that one, you know, it could be much, much larger than Jupiter, as has been said, 5 times the size of Jupiter. We've really never able to get, you know, a true measurement on that. It's just like damn near impossible. But because of the positioning of the Earth and the orbit of these objects, and the main object is really what we're concerned with, is that the activity that we see is always here on the eastern limb and here on the western limb. And that usually puts the Earth out of that bullseye zone. But as the coronal mass ejections get larger, we will eventually be in that grazing zone where the Earth gets grazed by this energy, the heavily charged particles spewing from the sun during these events. So as those events get larger, even getting grazed by one of these large coronal mass ejections is going to put the Earth kind of right outside of the bullseye zone. And, you know, what normally occurs? Earthquakes. Now, just yesterday, there were several big earthquakes. We're going to go ahead and zoom in here. You had this 5.3 here in Nicaragua, but what was even larger was this magnitude 6.7 right off the coast of Panama. And you can see it was right next to a fault line. So whenever we start to see these earthquakes popping, there is usually a direct correlation with what's happening on the sun. And for many, many years, there have been scientists that have stated, you know, activity on the sun has nothing to do with earthquakes here on Earth. Well, I think just what was it, like 2 years ago, all of a sudden scientists changed their mind, and after me talking about it and several other folks here on YouTube talking about the direct correlation with activity on the sun and earthquakes here on Earth, mainstream, lamestream science changed their mind. So these are some of the effects that we could look forward to if the Earth starts to end up, in that bullseye zone from these coronal mass ejections. Very large earthquakes. There's also the aspect, folks, of the additional radiation that we're going to get from the sun. We've all noticed over the last several years how strong the rays of the sun are. Even during mild days, when it's 74, 75, 76 degrees outside, no clouds, straight blue skies, and you can get out there and maybe there's a gentle breeze blowing, maybe the breeze is cool, but yet you can feel the intensity of the sun's rays. And it's, you think, okay, well, it's the sun's rays. Well, actually, what you're feeling is, you're feeling the heat from the sun, but take into consideration that you're also feeling the radiation from the sun. And that's why I try to stay out of the sun. For many, many years, I was a avid sunbather, man. Lived in Miami, went to the beach every weekend, always suntan, sunburn for all these years. I'm amazed that, knock on wood, that I've never been diagnosed with any form of skin cancer. But the rates of skin cancer have been steadily rising for years and years and years. And it's almost to the point where, sunscreen doesn't really work that well. And I showed all of you a couple of videos ago what happened to my best friend and his family when they vacationed just 3 weeks ago in Ocean City. Blistered with sun poisoning. My friend is still recovering. I was over at his house 2 days ago, and I asked him to show me his back. And oh God, I was going to take a picture of it and show it within this video, but it's just borderline gross, folks. So I don't even want to show that on my channel and have YouTube up my ass. But anyways, those two big earthquakes popped yesterday. Right here, we're looking at the CME tracker. You can see the latest coronal mass ejection. Boom, it is heading directly towards stereo A. So as that coronal mass ejection approaches stereo A, we might see a shutdown on data coming from stereo A, because they do have the ability, and they will shut down the electronics and transmissions during periods like this when there's a direct CME coming at this unit, and it kind of saves the electronics from being scorched and burnt to hell. But you could see that latest CME definitely not heading bullseye towards the Earth. As you could see right here on this side view, you'll see that glancing blow. And just like we saw on the predictor model from NOAA, again, a glancing blow. How strong the heavily charged particles will be as they approach the Earth in that glancing blow, probably not too much. We may see a little bit of earthquake activity, but again, we will see how that plays out. And I wanted to take a look and show you guys real quick what's happening on the sun. Now you could see how extended the corona is, and this is a composite view on the SDO. This is using the 171, 193, and the 211 angstroms of extreme ultraviolet light. Okay, so you see how the center part is relatively calm, but you could see the sunspots. You could see the activity here, 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 then down below, here, here, and here. And there's some brewing over here. So the middle, the equatorial region of the sun seems to be just kind of staying calm. If you're wondering what that jostling motion is, that is the Solar Dynamics Observatory's spacecraft recalibrating itself, and it does it ever so often, so it has a main straight-on view of the sun. And a lot of folks have asked me many, many times, oh, how come we can't see this Planet X crossing in front of the sun? Well, number one is because of the zoomed-in view that all of these cameras out there in space, that's the view that they are set up with. So they're not really set up with these wide angles where you could see the entire inner solar system. They are zoomed in, well, let's see, the SDO, I think that's about 1 million miles away from the Earth. So you're talking about zoomed in 92 million miles directly facing the sun. Same thing with stereo A. It is off to the left of the Earth, approximately 92 million miles away from the sun, and it has a zoomed in look towards the sun. So, you know, if they were to, and they probably have done this, but if they were to zoom out, which I believe they can probably do so, but if they were able to zoom out, and they probably have seen this object orbiting the sun. I have video of it that dates back to 2007, and I'll show it to you guys in a few minutes. But something that we're going to start to notice is the corona of the sun is going to start to grow. Now, in the past several years, when we were in this solar minimum, this corona around the sun was almost non-existent. Well, basically what you would see would be this, just the outline of the sun and just this little teeny tiny bit of corona around the sun. But you're going to see this start to grow. Where you could really see it is when we start looking at the SDO 171, which you're looking at on your screen right now. We're going to start to see this corona grow. And you are going to see all along this region, right along this line here, you're going to see sunspot after sunspot, coronal mass ejection after coronal mass ejection. We're going to see a lot of large filament releases, plasma releases, massive solar loops that you see here, these huge loops. It's going to be a very, very interesting 5 to 6 years as we move into this. So we're in 2021. So I would say, you know, within the next 9 months to a year, if we were to go back and look at this video and compare what we're looking at right now to what the sun's going to look like in a few years, a year, 2 years, 3 years, it is going to be just lit up like a sparkler on the 4th of July. And also, well, you know, that puts the Earth in that kind of a, I hate to use the word, but that kind of a danger zone where we're going to be subjected to more radiation and always the threat of the coronal mass ejection, boom, just heading straight towards the Earth. But as you can see, a lot of activity. We could take a look at the 304. This gives you just another view of the sun. And again, looking back just a few months, you really wouldn't see all of this, what looks like flaming activity on the sun. Okay? You would just see the red disk. But you could see the sunspots now. You'll see them in yellow. You'll see, well, there was just a nice flare that shot up right there. There's one shooting off right down here. They look kind of small on your screen now. But those are tens of thousands of miles long as they shoot off of the sun. So it's going to be a very, very interesting time. We could take a look at this disk. You could see this sunspot group here. There's a small one here, small one there. There was one there, and there's one turning right over here. So that makes 6 groups of sunspots, 3 northern hemisphere, 3 southern hemisphere on the sun. And this is going to be something that we're going to see more and more and more and more of as time goes on and we move into the solar maximum. What I've been talking about for some years now, well, probably like the last 2 to 3 years, is my fear of moving into the solar maximum and the interaction of the sun and these objects, especially the main core. What is it going to really be like this time around? That is the big question. And we are going to find out. I'm going to document every little bit of it. We will probably be getting into a lot more of space weather. Some of you may find it boring because I'm not always going to have photo captures of these objects. But just like we watch our regular weather here on Earth, space weather is also very important. Again, we're looking at another view of the sun showing the sunspots 1, 2, 3, 4, 5, 6, and there is a 7th that is rolling around right over there, and you will see it come into view. So again, folks, I mean, if there's really nothing to talk about as far as space weather goes, I'm not going to, come on here and do a video and bore you guys. But if there is something that is worth talking about, considering this situation that we're looking at right now, first time in a long time that we are looking at 6 sunspots visible on our disk, or on our sun. So moving down over here, we'll get a little bit of a better view of it also. Again, 1, 2, this one's very small, 3, but just because they're small does not mean that they cannot produce one hell of a blast whenever they are activated. So again, 1, 2, 3, 4th one down here moving in. You can see it right there. It looks pretty healthy too. Now, some of these are the sunspots that have already rotated around. Some of these are the sunspots that created some of the photo captures that we had a week, 2 weeks, 3 weeks ago. So they're moving around, and like I said, probably within, I would say maybe the next 5 to 7 days, we're going to start to see a lot of activity right here in this region. Remember, I'm telling you this right now. Okay, so this is the region that we're going to be paying very, very close attention to, because as this stellar core starts to move upward past the ecliptic, and it's getting close now. So as it starts to move upward past the ecliptic, above the ecliptic, that's when we're going to start to see the interaction. That is one of the closest points that this object gets to the sun. That's why, to answer a lot of questions, why do we always see this object on the left? Why do we always see this object on the right? Well, I've explained it probably, a couple hundred times. I'll explain it again. It is due to the elliptical orbit of this object. So it is coming in this pathway, like this. but way over here. And that is another reason why it's out of the camera's view. When it's way far below here, it's out of the camera's view. We can't see it. The camera can't see it. As it comes up around, then we start to see it. As it gets to about this point right here, it's in the camera's view. It's making a direct connection with the sun. The coronal mass ejections are occurring. And then as it loops back around to the backside of the sun, what do we see? We see coronal mass ejections on the backside of the sun where we can't see anything. And then it does pick up speed, makes its way here, and what do we see? Coronal mass ejections blowing off this way, and eventually this way, as the object is moving down. And then once it starts to move down, it's picking up that speed. It goes down below the ecliptic, and then it starts to slow down in its orbit. So it's kind of like a slingshot as it makes its way around the sun. Okay, so I hope that gives everybody kind of a better perspective of how this stellar core is moving, orbiting around the sun. I still get people emailing me and saying, "Oh, Scott, you're wrong. You're wrong. Nibiru is on a 3,500-year orbit." Well, look, okay, if Nibiru is on a 3,500-year orbit, it sure as hell is not within the camera views that we're looking at. And if it did come in and go back out, okay, case closed. We're not going to live another 3,500 years, so we don't need to talk about the mythical Nibiru because none of us have seen it. But what we are dealing with is we are dealing with something in reality. We're dealing with other objects that have entered our solar system at some point in time, as early as 2007. There's a high possibility at that time in 2007 that their orbit was a little strange, bigger, and as the years went by, the sun's gravity has pulled this object and several along with it, and that orbital path has now shrunk down to approximately 28 days. Just like all of the other planets in our solar system. As long as these objects stay in motion, they will not be sucked in by the sun. They will not be expelled out of the solar system by the sun. If you take, for instance, the little rocky planet of Mercury, approximately 48 million miles away from the sun. Well, why doesn't it burn up? Why doesn't the sun suck it directly in and destroy it and obliterate it? It's because Mercury is in an 88-day orbit, moving pretty quickly around the sun. And as long as Mercury stays in orbit, it will not get sucked into the sun. So I hope that answers some questions. I've been getting a lot of, emails and comments and things of that nature asking me those specific questions. And, the trolling on YouTube is just absolutely horrendous. People trying to goad me into these crazy comments on YouTube. And, I won't even go there. I've been doing this long enough, folks. I know when someone's trying to bait me into, the comment section and criticizing me. Look, I'm used to the criticism. I'm used to all the debunking and all that crap. Bottom line is, we see what we see almost on a daily basis. We see the activity. I'm going to jump over here to seeds real quick. But we see the activity. We are able to document what we are seeing, when we are seeing, And the amount of evidence and data that I now hold is huge. Absolutely massive. The photographic evidence that I have is huge. Matter of fact, let's take a look at something here real quick. I'm going to show you guys what I mean from the video from 2007. Okay, so this was video that was leaked to me by a New York Times investigative reporter. She leaked this to me in 2016. This information was leaked to her in 2015, I think it was. She really didn't know what to do with it, so on and so forth. And she was actually kind of a space buff. And she was actually like watching my videos on YouTube and decided to leak this information to me. And there has been all kind of criticism by the trolling community that what you're seeing on your screen right now is our moon. Our moon. You know, the one that you go outside when it's the full moon and you look up in the sky? Okay? That's pretty stupid. That's one of the dumbest comments that I've ever seen the troll community make, is that that is our sun. I made a better video of this. I think it's right here. Yeah. Yeah, this will start to go ahead and load. So you can see, and this was from Stereo B. Stereo B is no longer in operation. Just all of a sudden, you know, they claim that during a calibration roll, the spacecraft lost communication with its ground command. And it's just floating around out there in its position, but not sending back any data. I don't believe that, folks. The reason being is because we have Stereo B to the right, Stereo B to, or excuse me, Stereo A to the left, Stereo B to the right. Okay, well, what that means is we would have a pretty damn good view of the sun at all periods of time. So for those of you that kind of complain that, you know, we're only seeing this one view, well, folks, that's the reason why. They took one of our satellite cameras out of the mix. And what you're seeing on your screen now is the reason why. Is because instead of getting views of this object every 2 weeks, we would be getting views of it every stinking day. And the evidence would compile faster and faster. I wish we had access to Stereo B. It would be pretty amazing to get these better views. I slowed this down during this clip. And again, this is going all the way back to 2007. My hypothesis is that during this period of time, this object had a much larger or longer orbit around the sun. And I don't know how long it was. It could have been months. It could have been a year, or I don't know. But as each orbit went by, the sun's gravity shrunk that orbit more and more and more and more until approximately 3 years ago, it kind of settled into this 28-day orbit. And I worked on that for like 3 years. 3 years documenting every coronal mass ejection, every single sighting. I mean, I had it all written down in several notebooks, like, dates, times, places. And then I started putting all of it into an Excel program in one of my computers, and then kind of, hashing all the numbers together. And it basically came out with this 28 days. Every 28 days, we're getting views of this object. Every 2 weeks, every 10 to 14 days. So that's kind of twice a month. Interesting. But again, due diligence. I did my homework. I documented things the best that I could. I thought, maybe I'm right, maybe I'm wrong. But as time continued, the 28-day orbit just kept proving itself. Week after week, month after month, and now year after year. So, for all of you folks that, are kind of new to this type of research and this type of evidence, look, there's a lot of credible evidence out there. I have tried to produce the best that there is. And it's been tough. It's been hard. A lot of it is unbelievable. But folks, when it's staring you right in the face, what are you supposed to think? Is it still imaginary? Am I crazy? Is this guy putting on a hoax? What would the reason be? I'm not making millions of dollars off of this. This is actually pretty much, I don't want to say ruined my life, but it's turned my life in a direction that I wasn't planning on going. It's kind of been a big disturbance. But I feel that the world needs to know. The world has the right to know. Just like when you talk about UFO disclosure. Okay, I think we're ready for it. Let's get down to brass tacks, Mr. Government. Show us the evidence. I think we can handle it right now. But, we still get bits and pieces of that UFO evidence. They kind of give us a little taste, and then they pull it away. What I do is I bring you the cold hard facts of what I am finding, and I don't have all the answers, and I may be wrong on some things that I form a theory about, but I know one damn thing. When we get visual evidence, what are you going to say? Oh, it's not there? Oh, it's photoshopped? Look, folks, I'm no graphic artist. I'm no animator. But I was lucky enough to get some help from a colleague that, is a professional, has access to very, very sophisticated software that's only been around for a few years, and it's even still in development. And it has helped this community see what is really there. Maybe sometime in the near future, we'll be able to get even clearer observation. But the fact of the matter is the other technology that we're dealing with, meaning the camera systems on these spacecraft and the quality of the data that is uploaded from the coronagraphs for public viewing. So I don't think that's ever going to change. I don't ever think they are going to give us, 4K ultra high definition access to these coronagraphs. Just probably not going to happen in this lifetime. So I hope that, some of this information here towards the end answered a lot of the questions that some of you had. So stay tuned to Planet X News. Folks, also make sure that you are subscribed to this channel. Always check your subscriptions. Okay? If you don't hear from me on my YouTube channel, more than maybe like a week to 10 days, then just come back to Planet X News, the YouTube channel, and check and see if there's a video that you've missed. And at that point in time, check your notifications. And you want to check that notification and make sure that you are notified of all videos that are uploaded. Okay, so that should definitely be your choice. So folks, in the upcoming week, a lot of activity going on the sun. In about 7 to 8 days, we will probably get some new views, new coronal mass ejections forming on the western limb as our object makes its way up from the ecliptic. So my last words, stay tuned to Planet X News. Be safe out there, folks. Thank you for your support. Thank you for watching. Take care.